correlation, and we'll actually we're going to talk about the main part of correlation today, but we're really going to have some extra material to talk about um, in the coming periods. So correlation measures the strength of a, and this is big, linear association. Of course, between two quantitative variables. So correlation is linear strength, all right? And as such, if the relationship is not linear, then correlation is not appropriate. Not linear, not appropriate. All right, so if we do not have a linear relationship, then we don't have correlation. So for example, let's say this was my scatter plot. How would you describe the strength of this relationship?
First group. So it's not corn.
No. How would you describe the strength? How would you describe the strength? That's what my question is. How would you describe the strength of this relationship between some variable x and some variable y? Just the strength. Is it very weak, weak, moderately strong, strong, very strong? Those 5 levels.
Some moderate strong.
No. No, it's not moderate.
I think it's very weak because it's not linear.
It's very strong. And this is also why I do this one. This is incredibly, actually, I want to say incredibly. Oh, okay, I'm having trouble spelling that word. Very, very strong. Very, 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 very strong. This is probably as strong as a relationship can get because all of the points basically line up right together. It's perfect. There's a perfect relationship. Think about it this way. Could you fit an equation to this? And as Darwin was trying to mention, he was trying to say what he saw, and he saw a quadratic. And the idea there is that you can write an equation, and the equation would pretty much hit every single point. So you have a perfect relationship in this one because you can draw that. So this relationship, this association is very strong. So there is a very strong association. It's a very strong non-linear relationship. It does not need to be linear. They're mutually exclusive. All right. It's very important to note that just because something is linear or non-linear does not, I guess I would say independent, not mutually exclusive. They're independent of each other in regards to how one affects the other. You got to look at the picture at hand. However, the correlation for this is 0. Sorry, I haven't taught you with that. There is no correlation here. However, it is very strong. So a lot of people get very confused in this, and this is the first piece of really conceptual understanding that you need to get. And do you understand what correlation is? Correlation is linear strength. All right. So what we're seeing here is that there is no linear relationship. That does not mean, but there is a very strong nonlinear relationship. So a lot of people look at the correlation and they say, "Oh, there's no correlation here. There's a weak strength, but that doesn't. There's still a very strong strength. It's very strong here. You can fit an equation, and the equation would perfectly touch every single one, or come really close to touching every single point. That is strength. Okay." Um, but there's no correlation because there's no linear. There's no linear relationship. It's a quadratic in this case. You can't really fit a line to these points without missing a drastic amount of these points. Does it go up? Does it go down? Well, in this case, the the direction is both negative and positive. And that's when you know that there's no if you say, oh, this could be a negative relationship, oh, this could be a positive relationship. If you can't determine which one of the two it is, or it could be both, then there's no correlation. Correlation. Okay. Um, Hold on really quickly here. So this is a visual representation of correlation versus causation. This is something I mentioned. I told you I wanted to show you this video. The person there is pushing the truck from inside the bed and it's moving forward. There is an association between how much he's pushing and the truck moving forward, but he's not causing the truck to move forward. The other people behind are causing the truck to move forward by pushing it. So first off, there's a lot of different things to unpack here. First off, correlation is a measure of a linear relationship. Correlation is a subset of the word association, but specific to linear. But most also importantly, just because there is an association, just because there is a relationship, just because there is a correlation, does not mean that X causes Y, as you can see in this picture. Okay, so let's talk about correlation. So we have what is called the correlation coefficient. And the correlation coefficient is the letter R. Okay? R is the letter that we use for correlation. R is a numerical value that for correlation. All right. So correlation, we talk about is there a correlation? The correlation coefficient, but typically we'll just say the correlation R. R is the correlation. We just dropped the coefficient part, but that's the technical name for it. R is a numerical value between -1 and 1 that measures linear strength for a relationship between two variables, two quantitative. There's a common AP exam question, and I want to note this to you because I've already seen some of you answer this question in regards to your assessment that you had turned in the exam. Whenever a question says something like, comment on this observation, typically that means there's something that was statistically done wrong. 95, 98, 99 times out of 100, it typically means that there was something that was done wrong. That what they're saying is wrong. What they're saying is misunderstood. So a lot of times it happens, they'll say things like, there is a correlation between your course and your grade. comment on this observation. Can anybody comment on this observation? There is a correlation between the course you take and your grade. Can anybody comment on this observation? Something that happens all the time on your exams, on homeworks, on AP exam. The statement is there is a correlation between the course you take and your grade. Comment on this observation.
I'm not going to comment, but you can repeat again. We cannot say here a few minutes, so I cannot listen to everything what you say.
I don't know what you just said, but okay.
No, I said you can repeat again because I'm not stay here a few minutes.
Okay. So there is a correlation between the course you take and the grade you have. Comment on this observation. Amy?
Does it basically mean that there's a correlation between the grade that?
What did I just say what did I just say that happens when I say the word comment on this observation?
Like it's wrong. There's
It's
something
wrong. Correct. There's something wrong.
Basically,
it's not true what I'm saying.
People think that just because they're taking a certain class, they're going to get a certain grade.
No,
that's not necessarily true.
No, it would be valid to say that there is an association. Let me give a hint. It would be valid to say that there is an association between the course you take and the grade you get. That would be okay. There's nothing technically wrong with that statement. We just have to back it up. But what is wrong with the statement? There is a correlation between the grade you get, between the course you take and the grade you get.
Is it that the course you take doesn't determine exactly what grade you're going to get?
No, well, that's causation. You're talking about causation.
Okay.
If I said something like, we'll get to those questions as well. If I say something like, there is a correlation, so your teacher makes let me see. Let me switch the problem here. There is a correlation between. No, that would be. No, so we'll just keep going that way. The problem here is what I'm trying to say is, what type of variable is the course you take called? What type of variable is the course you take? Course taken. What type of variable is that? What type of variable is course you take? Anybody? You only have two. It's not quantitative. It's categorical.
Categorical.
It's categorical. The course you take is categorical. You take this course, or you take this course, or you take this course. There's no numbers involved. There's no sequential numbering involved. The problem that I'm trying to tell you here is that there's a big problem here, and the problem is the misuse of the word correlation. That always happens with so many individuals, and it's frustrating to me as a statistical teacher when people say statements like that, because there's no such thing as a correlation between a categorical variable and a quantitative variable. Does that make sense? So the problem is that the course you take is categorical, and correlation is the relationship between two quantitative variables. Okay? Correlation is specific to two things, as we just seen in this. Correlation, the word correlation is specific to two things. One, two quantitative variables. So if we do not have two quantitative variables, bad, bad, bad. The second word is linear. It measures a linear relationship. Now, we might have to assume that there's a linear relationship, but unless we see a scatter plot of some kind, but it's a measure of linear strength, okay? The correlation coefficient. So that's what I wanted to try to talk to you about. It's between two quantitative variables. And so if we don't have two quantitative variables, you cannot say the word correlation. There's not two quantitative variables. There is no such thing as correlation. You can say that there is an association. All right. For example, a lot of people will say, there is a correlation between if you show up to first period and your grade. Well, if you show up to the first period is a yes or no question. And that would be categorical, which means correlate. There's no such thing as correlation. There's no linear relationship between something that's categorical and quantitative. You could say there's an association between making it to first period on time and your grade. You can say that there is an association, and there probably is. But here's the other concept here, and as I wanted to relate association, and I just want to reiterate this from yesterday's at the very end of the class. Association or correlation, or let me just actually just do correlation. Correlation does not mean causation. I want to reiterate that. I got to reiterate that over and over and over. Just because, and as you saw in that image that I just showed you briefly, the word correlation does not mean causation. Just because there is a correlation between two quantitative variables does not mean that one variable causes the other variable to go up or down. Okay? So, for example, all this I'm trying to say verbally to you. It has been found that your attendance, your homework percentage, okay, there is a strong correlation. Let me actually just do this. There is a strong correlation between the amount of homework completed and your grade percentage. Nothing wrong with this statement. I'm stating that. A student does more homework and is angry, their grade went down. There's a strong, so I want to say there's a strong positive. I want to even note that there's a strong positive correlation. All right. So the student's pissed. They're like, well, you said that there is a strong correlation between doing homework and the grade. So if you do more homework, does that mean shouldn't my grade go up? And I get these all the time, and I'm just like, okay, well, you think there's a causation. That doesn't mean the fact that if you do more homework, it doesn't mean your grade will go up. Okay? There is not a causation. All right? Correlation does not mean causation is the solution to this problem. Just because you do something does not mean the other one is going to cause, unless we know for a fact it's a causational reality. There's still other things. So instead of amount of homework, you can do this with attendance, for example. This happens all the time for attendance. A student doesn't come to school, has all kinds of absences, misses lots of classes, failing. So then they are like, okay, so they have a conversation. You're having trouble with your attendance. Let's bring that up. So they start showing up. Their grade is the same thing. They still failing the course. But I'm showing up to school. I'm showing up to class. Why am I failing then? Well, showing up to class doesn't cause you to get a passing grade. There's a relationship. Most students, on average, in general, students who have better attendance have better grades, but that doesn't mean better attendance causes better grades. This is the idea of correlation and causation and how they differ with each other. All right. So think about those ideas, because there's other explanations, as we're going to come and find out in tomorrow's lecture or material. There's other reasons that could explain how grades can go up. It's not just showing up to class. While there might be a strong relationship, correlation between it, does not mean doing one changes the other. Does that make sense? Yes, yes. All right. I'm going to save the calculator piece for tomorrow. All right. I think it was good just to have that conversation. I'm going to save the calculator piece for tomorrow. I'll probably have to adjust the homework as such and take off any of the problem that has that part. So let's talk about R. You can think of R. It falls under number line. Now, I told you about the values of R. What do the values of R? This is a number line for R. What is the left side of this number line? What am I going to label it? What am I going to label the left side of this number line? I just told you about R, the correlation coefficient. -1. And what am I going to label the far right side of the number line?
1.
1. A lot of people will be like, oh, the correlation was 1.3. Comment on that observation. Oh, correlation cannot be 1.3. Correlation must be between -1 and 1. There's no such thing as a 1.3 correlation, with 0 being right in the center. So first off, if R is 0, that's of course no correlation. We've already talked about that. But what do values of R up to here mean? What do these values mean? What does that tell me if R is negative? If R is negative, what does that tell me?
You said that's going to be negative?
Yeah, it's a negative what? And there's a negative relationship. So if I'm describing it, it's going to be negative. And what about if we have a positive value? What does that mean?
It's a positive relation.
Yeah, positive relationship. Now, we defined 0 as no linear relationship. Okay. R equals 0 is no linear relationship. And R equals 1 is a perfect linear relationship. I had said very, very, very strong. We'll say it's a perfect, meaning that I can fit an equation like y equals mx plus b, and it would hit every single point. All right, just like you've done your algebra points. So that means that if we were to be right here, what would you define a value of R to be that's right there? If R lands right there, very close to 0, how would you describe that relationship? Where 0 is no relationship and 1 is a perfect relationship. What would you define this if R was right there? Remember, we have 5 ways of measuring. We have 5 ways. Yeah, so what's another way?
Very strong.
No. Opposite. Very weak. Very weak. And what would you define something that's very close to 1?
That would be very strong.
That would be very strong. So now, what about if we were on the other side of 0? What would you classify as something that was like negative 0.01? Very weak. But it would be a very weak negative relationship versus a very weak positive relationship. So the sign of R tells you those ones. So typically when we look at R, we look at the absolute value of R, measures strength. Okay, so a number that's very close to -1 would be
Strong.
very strong. Okay, so the closer you are to 0, the weaker the linear strength. The closer absolute value of R is to 1, the stronger the relationship, the strength. And when I say absolute value of -1, I mean closer to -1 or closer to +1. All right, so you can get closer and closer to -1 or +1. So that means, and now let's focus in on the positive one because everything is just a reflection on the other side. So there must be some definitive cutoffs that we have. And why are these cutoffs what they are? They're used mostly as a guideline. They're not definitive, but for our purposes, they give us a very good idea of what's going on. All right, so the first cutoff is 0.5, or I'll go 0.5, right in the middle. All right, and the reason why this is, it'll make more sense tomorrow because 0.5 squared is 0.25, which is 25%. 25%. If I told you I can give you 25% of the solution, would you be comfortable? Would you be satisfied? Probably. The idea is you go with it. You wouldn't be ecstatic, but if I gave you at least more than 25% of the answers, you'd be okay. You could work with it. All right. And the other one is 0.3. So basically, any value of R between 0 and 0.3 is considered very weak. 0.3 squared is 0.09, which is very close to 10%. If you have less than 10% of knowledge of what's going to happen, you don't really have much knowledge of what's going to happen if you have only less than 10% of the idea. That's basically what we work on. And if you fall within 0.3 and 0.5, then what are you going to do? What do you think the answer? What type of strength? What kind of strength do you think it's going to be if R is between 0.3 and 0.5?
Strong.
Okay. So we can't go from very weak to strong. You're going to go from very, very weak to weak. It's a progressive. The next one is 0.7. And so if R lands between 0.5 and 0.7, we typically consider that to be no. Look at yesterday's notes.
Is it moderate?
Moderate. I'll say moderately strong. I like to say moderately strong, but moderate. And if R lands between 0.7 and 0.9, we say, there we go. That's where the strong is. Okay. So it's a progressive system of going from very weak to very strong. All right. So these numbers of R, that if I give you the number of R, then it kind of tells us what it is. Now it's a good idea that we must note, if only given R, you know nothing, since need scatter plot. More importantly, that there is a linear relationship and that there are no outliers. We'll talk a little bit about how outliers can be problematic. So what I'm trying to point out here is that if I told you R is 0.5, now you might assume, so you may assume linear relationship and no outliers. But typically, you gotta read the problem, read the room. I like to say it. You gotta see if the problem itself is. Some problems are asking you to actually explain R. Okay. In other words, they want you to say things like very strong, very weak, very negative. So is the problem asking that? Some questions are really just testing you not to actually do the explanation, but some questions are actually testing you to understand observe this information. Is there, they're what they're saying, you know what? I can't say that because if I look at the scatter plot, it's not linear. So there's something wrong with the statements. Now, they could say just do it. The problem can also say that even though it's not true, do it. That happens a lot in this type of topic. Even though there's not a linear relationship, solve this problem like it's linear. What would you get? And then typically after the fact, there's a follow-up saying, all right, we know it's not linear. How would you actually do it? As we have like 2 more weeks of this type of material to be able to do. If a scatter plot, if a relationship is linear, it is common practice to include the correlation coefficient R. Okay, so remember I told you if there's an outlier, yesterday's lesson I told you that if there's outliers, it's common practice to do what? If there's an outlier, what is it common practice to do? I mentioned this yesterday. If there's an outlier and you're describing the relationship, what should you also do? Write the points. Exactly, Armani. You state the points. Where is the outlier? Okay, it's very important that you state where the outlier is. That was from yesterday. If there's a linear relationship, what should you also do? $1 million question. If there's a linear relationship, what should you also do?
Create scatter plot.
No. The answer's on the screen, people. If there is a linear relationship, you should do what?
Does it include R?
Include R. If it is known or can be found. I'm not trying to blow your minds here. You should include R. All right. So if the problem states what R is, so I really don't feel like I can do the problem with the data in the time that we have. However, what I am going to do, and you can help yourself do it, and this is mostly for tomorrow's assignment. We're going to look at some data. So tomorrow, I'm going to start off by plugging this information into my calculator. So I'm going to start us off here. I'm not going to do it all, but we're going to talk about problems with data. I'm not going to assign a problem with homework, but we're going to do, and let's say that we were collecting data on people's heights, students' heights, and their shoe size in men's U.S. and U.S. men's size. Okay, so here, actually, let me edit this down a little bit. I think I can fit everything. So my numbers, my data, I'm going to write the data down. This is more for tomorrow. 56, 3.5. It's going to be a lot of numbers here. This is in preparation for tomorrow. See, 60 and 3. This is height, and this is height in inches. Okay. 61 and, or sorry, another 60. This is a different person. And 6.5. 61 and 5. 67 inches, shoe size of 9. 61, shoe size of 4. 60 inches, shoe size of 4. 63 inches, shoe size of 7. 62 inches, shoe size of 5. 64 inches, shoe size of 7. 66 inches, shoe size of 5. 64 inches, shoe size of 7. 60 inches, shoe size of 5. 66 inches, shoe size of 5. 60 inches, shoe size of 5. 67 inches, shoe size of 10. 68 inches, shoe size of 12. 70 inches, shoe size of that's another 10, sorry. That should have been 10. 70 inches, shoe size of 12. 67 inches, shoe size of 11. 67 inches, shoe size of 10. 74 inches, shoe size of 14. 71 inches, shoe size of 10. And 68 inches, shoe size of 9. Now this data is actually the data that I had from my last year's class, and the left side was the female heights and shoe sizes in men's, and the right side was the males within the class, their heights. That's why they're trying to be taller, and their shoe sizes. But we're going to put all this data just together. I want us to be able to do this. We're going to use the graphing calculator tomorrow. We're going to talk about how we can utilize the calculator. We're going to make a scatter plot of this to start tomorrow's class. I want you to note that you should be utilizing an app, such as Calculator. So everybody, however by means you have, and so I'm putting this out there very clearly. You need to be having a calculator app in order to do this. I don't believe, I haven't even tried Desmos yet. I think you can do a table, and you can put in the points. Let's see. Yeah, it'll find the correlation in the end. It will do the work for you. I don't recommend it. Desmos is if you absolutely don't have anything, but here's the point. You're in AP Statistics. You should have better technology than just what's on there on Desmos. So what that means here is that tomorrow you're going to need an app to use. And we input the data just like we inputted the data. If you've inputted data like this before, you're going to hit stat and then edit, and you're going to put all these numbers into here. I haven't done it yet. All right, so this is what we're going to want to do. So tomorrow you're going to check your homework, and I'm going to give a little bit of time to be doing this, but you should be doing the numbers there and having this ready for tomorrow. So like 56, 3.5. I would go just straight downwards when I'm doing the numbers. So I would do like 60, 60, 61, 67. And you can see, be careful on how you touch the screens. I'm using a touch screen here, so if you're a little too fast, you'll miss the numbers. So input the data into there. I'm going to finish inputting the data tomorrow, right when we start after the first 5 minutes. Be prepared to have this for tomorrow's class. In the homework, I'm actually taking off the final problem 36. So I'll be updating it because 36 was a problem with data. I'm going to eliminate that one for tonight's homework. That's what I have for you today. The homework is on Google Classroom. See you tomorrow.